So there are different classification of discrete time signals. It may be different in different textbooks, but according to our standard textbook, let's take these four classifications of signals. First classification is energy and power signals. If we in both these we have these basic formulas, that is E equals to n equals to minus infinity to infinity x of n. It can also be written as E equals to limit n belongs to infinity sigma small n equals to minus n to n x of n whole square, and power is given by limit n belongs to infinity 1 by 2n plus 1 summation of n equals to minus n to n x of n whole square. This represents the modulus. Modulus means even if you take minus 2 also, by applying modulus we get positive 2 only. Okay, here the limits are taken from minus infinity to infinity in this formula, and it can also be represented by taking the limit in starting of the formula. Here this is the only extra term between the energy and power formula. So by substituting x of n here, we get whether the signal is energy or power signal. For energy signal or power signal, both have to be less than infinity, so that the signal is between 0 to infinity, it is energy signal, or 0 to infinity is a power signal. But for energy signal, power is 0, but for power signal, energy is infinity. Have to remember all these things. Okay, next going to the second classification, periodic and aperiodic signal. Signal is said to be periodic if it satisfies the condition x of n equals to x of n plus n. That means periodic means it have to repeat itself for intervals of time. Means it can be shown like this. For normal continuous time signal, consider a sinusoidal signal, it is represented like this, as it repeats itself from here to here. After some time it repeats itself, so it is a periodic signal, and this interval is taken as the time period. Similarly for discrete time signal, you can represent like this. This is the time period t, and it again repeats itself after some time period. So this can be checked by using this condition x of n equals to x of n plus n, where here n is the fundamental time period. Okay, let's go to next classification, symmetric and asymmetric signals. Symmetric signal means x of n equals to x of minus n, means this is a symmetric even signal. Some of the examples of even signals are cosine signal. This is an even signal. And odd or asymmetric signal equals to x of minus n will be equals to minus of x of n. It is represented in simpler form here. X of n equals to minus of x of minus n, so that x of minus n is minus of x of n, and minus of minus x of n means minus of minus x of n will give x of n. Okay, x of n is a signal which consists of even parts and odd parts. So by following these let's solve this by using a sequence of steps. By substituting n equals to minus n, we get xe of minus n plus xo of minus n. As xe of minus n is an even signal, we get xe of n, and xo of n gives x minus of x of n, so that we get x of n plus x of minus n equals to 2 of xe of n. And similarly, x of n minus x of minus n gives 2 of xo of n. So we have to remember this formula, xe of n equals to x of n plus x of minus n by 2, and xo of n equals to x of n minus x of minus n by 2. Both these are very much important formulas which will be used in further calculations. And next, coming to the next classification of discrete time signals, we have causal and non-causal signals. Causal signals are the signals which exist only for even time period. No, sorry, not even time period, only for positive. Means it goes on like this only, and does not exist for negative 0, 1, 2, 3. It exists only for this positive time period and does not exist for negative time period -1, -2. So a signal, it can be defined as, in simple, a signal which exists in positive for n greater than 0 is called causal signal, and signal which exists for n less than 0 is called discrete time signal. So it is given like this. The basic causal signals are unit step u of n, where u of n is given like this, 1, 2, so on till infinity, 0, 1, 2, 3. All time its amplitude is only 1. X of n equals to a of n, u of n. All these exist only for n greater than 0. For n less than 0, the x of n equals to 0. They does not exist. Okay. X of n, non-causal signals are the signals which exist for negative time period also. These are x of minus n plus 1. Minus n means u of n is, this is u of n. U of minus n means time folding have to happen. You have to fold it such that it appears as a mirror image. So 0, 1, 2, 3. Okay, minus n plus 1. Plus 1 means when using this plus 1, it have to shift right. So it will start from here, minus 1, minus 2, minus 3, sorry. Here it is plus 1. So it exists in negative and positive. So it is a non-causal signal. Mostly the even signals are symmetrical. Even signals, cosine. See, cosine, cos 0, 1. So it is given from here. All the cos signals are symmetrical about vertical axis. Means it is symmetrical because of this vertical axis. We can say it is symmetrical, as it is equal on both sides. And odd signals like sine signals are asymmetrical about vertical axis. Means they are given like this, sine 0, 0. So like this they are represented. Okay, don't confuse. Sine signals are represented from here. So they are asymmetrical about vertical axis, and they are symmetrical about horizontal axis. They are symmetrical. See, like this, up down are same. So they are symmetrical about horizontal axis. Horizontal axis is this one, the time index representing axis.